And this next part is on SNOMED and the information model. It is really talking to many of the things that I've already said, but it's going a bit more into the detail of it. And it is really, really key for anyone implementing SNOMED CT or involved in implementations that they understand this. So it's called SNOMED CT and the information model. It speaks about terminology binding. So let's just get started. And you can see I have a long outline for this, but let's focus on the dark ones. So first I want to teach you about what terminology binding is, some principles for terminology binding, and then I want to show you some different examples, probably more examples than demonstrations here. If we have time, we are going to talk about show you an example how proper terminology binding supports interoperability. But otherwise, this may be something that we can speak to at a later session. So what is terminology binding? Well, many people have many ideas about how health IT can really revolutionize healthcare. So we have many anticipated benefits of when we introduce a new IT system. We may end up having increased efficiency and accuracy. We can have improved data accessibility. We can now start to share. We will get enhanced patient care because we have real-time access to information. We can have improved data analytics, decision support. We will have a better opportunity to collaborate and use our data to communicate between our colleagues. We can have enhanced patient safety because we have less errors. We will have improved documentation with more complete and accurate picture of the patient's clinical journey. And we'll also be able to utilize that for billing accuracy and revenue. So wow, that's really a lot of benefits that you can gain by introducing health IT, or at least that's what we anticipate. But it's not just, you just don't get that by introducing an IT system in healthcare. I can assure you, you really need to do it in a proper way where you have actually thought about what are the benefits you would like to achieve. So it's not enough just to taking your paper-based record and then plugging them in and having an IT representation of that. If you do that, some of the early IT systems in healthcare, they were taken where if you had a paper form before, you would take that paper form and you would construct it exactly the same way, so that when you moved to IT, it looked very much like what you had on paper. It was just in a digital form. And the benefit of that is that it, of course, increases the recognizability for the clinician. It also makes them maybe more positive and appreciative of starting to use an IT system where they were using paper before. The problem with that approach is that if you haven't thought about interoperability and reuse of data, then this approach will not support it automatically. So you need to think about how is it that we can take what we have done on paper before, put it into an IT system, using standards to actually achieve some of these benefits that we desire. And when we start to standardize our IT system, there are two areas where standardization is particularly important. The terminology is one part, and then the information model. So the terminology and the information model is essential when you standardize your electronic health records. The terminology side of this is what we've talked about the whole morning, about SNOMED is a terminology. There are other code systems and classifications, and there are also other terminologies. And SNOMED CT is the world's most comprehensive clinical terminology. And it serves to provide a controlled vocabulary of all the phrases and concepts that you want to record, just as you have learned this morning. The information model, on the other hand, is used to model objects at a more conceptual level. So it could be, for example, if you want to do a blood pressure. So we have a blood pressure measurement, or I want to do a request for a procedure. So the groups of clinical information that is required for particular purposes. So a model is used to group objects and represent larger groups of information that should be understood together. And that is especially important, for example, if you're transporting data. It's not just sending a code, no, it's actually sending a code in a context so that it can be understood. So this is where we are normally just speaking to the features of SNOMED CT. I'm going to skip that because you know all of this already. SNOMED is a graph. It has codes. It supports descriptions in different languages. Each codes represent a clinical meaning that is defined. And we have many hierarchies to represent signs, symptoms, and all of this. You have already seen this. So that is the terminology part. Now the information model. There are many types of information models. It took me a long time to actually understand the term information model, really, because think about it. Information model, we may think about different things. Some of us will think about how a user interface look, the model that we use to say, well, here is a data entry field looking like this. Here is another data entry field looking like that. It could also be database designers will think about, okay, how do we store this information? We need these database tables with these attributes. They will think about how information is stored. In a more national or at a higher level, that is regional levels or national levels, you may think more about what are the ways that we capture information about diseases or mortality in our country. Or in this region, how do we register all the patients that have infections in this region? Something, or new incidents of diabetic ulcer, something. So there we have some more. These are the codes and concepts we're using, or these models that we used in a region, nation, or internationally. Then we can also have communication models, and these are the ones that are important when we share information. So when one hospital wants to share something with another hospital, for example, the result of a laboratory test, what is the model that we use to represent that information? So you can see there are many types of information models, and they all are models that model information, and they are all used in different ways. So one of the models that we speak very much about these years is FIRE, which is a communication model. And FIRE has a range of resources. For example, FIRE specifies that you can, if you have a patient resource, a patient may have a name, it may have a phone number, a gender, a birth date. So there are many things that when you want to represent this is a patient, well, it's not just a patient identifier. No, there's a range of information associated with that patient that we will represent as well when we are transferring a patient, for example, to a different place. There's another resource in FIRE for procedures. Again, it's not just a procedure code. No, there's also a status for the procedure. There's also who has recorded this procedure. What was the reason for this procedure? Was there any complications? So there's a range of information that can be associated with a procedure. And again, you can see that it can also be associated with a performer of the procedure and a focal device, which are other resources. So this is to show that generally FIRE represents these models that can be used when we want to share information. Sometimes people will think, well, it's just enough to have, we're using a standard terminology. Yeah, but you really need to always interpret a code from SNOMED in the context that it was entered. Another commonly used FIRE resource is the problem condition resource. We are not saying that you have to use FIRE for everything here. This is just a very well documented information model used for which can be used for messaging. Other information models can be just as good. We're just using this as an example of a model. So in FHIR, you could see that they had all of these different things. This is a condition. So a condition can have a status, a verification status. A condition can have a severity. This is the actual condition code, a body site. So these are all the things that can be recorded about a condition. And when you go into the specification for the condition resource or problem resource, and you look at these different fields or data elements in more detail, you can see that some of them is an identifier. That's an ID for this particular condition. But then a range of them may have this codable concept. And every time you see a codable concept in a resource or in an information model, this is probably where you can think, hey, maybe I can use a SNOMED CT code in this field. For example, for the severity attribute, you can use conditions, diagnosis severity, and we have codes for that. For the actual condition code, it's a problem or diagnosis code, so that could be all the descendants of clinical finding in SNOMED, and it could the actual set in a specific situation could be even narrower. And the body side, and you can see it could be all the SNOMED CT body structures that could be recorded there. Sometimes the specification in FHIR would use SNOMED CT, and other times it will be more optional that you can use SNOMED, but you could also use another. So in that way, SNOMED and FHIR is not married, but they just work very well together. This is an example of a condition resource with some identifier, in this case stroke. The coding here is that it's an active. The clinical status, is that this one is an active condition. The verification status of this is that it's confirmed. So some places FHIR has defined their own options. You could even, for verification status, if it was suspected or something, you could even have added a SNOMED code here. But under, let's go down to the code option. So the code for this condition is where you can see that the coding includes both the system and the code, the SNOMED code, and the system will tell us that this is a SNOMED. This is the URI. We have a URI specification, and this is the URI that you use to say, well, the code system this comes from is SNOMED. The code is this one, and the term display is the fully specified name, but the text that is associated stroke, which was the one that was probably displayed in the system at the point of data entry. So if you look at these various codings, you can see that the system will tell you where it comes from. These are HL7 specific value code systems, and this one is the SNOMED CT one. So that was a bit of background on the terminology and information models. And the point about standardizing our health IT systems and how to do that is that you perform terminology binding so that you make the terminology work well with your information model. So you need to appropriately bind the terminology to the structures in your information model. So terminology binding in general is that we have a link between a data information model artifact and a terminology artifact, and that you have the additional metadata that is required to interpret the binding. And why is this important even? Overall, it is essential so that we can have high quality data that can be utilized. So terminology binding, as you saw in the UI demonstration, that is actually where we had a field bound to procedures. That is actually a terminology binding. We have bound the field to all the set of procedures. So in that user interface, we have said that the values in this field, or this essentially a data element in a storage model, Well, that will come from the procedure hierarchy. So it will make sure it will support faster and more accurate input of data, and it will also support the data quality and utility, because each field, you make sure that each field and the values that you apply in a field comes from the right domains. And that is very, very important when you want to do data analytics and clinical decision support. If you think about the table I showed you before with the example from the UK, where they have entered many different types of concepts that were not really diagnoses. Well, if you are entering that kind of data, that was not going to trigger a decision support alert if your alert has been set up to only react to some kinds of diseases, for example. And then, of course, it supports interoperability that we agree on, that we can understand the meanings that are transformed between systems or exchanged between systems. But why is terminology binding difficult? So now I'm claiming that it is difficult, but that's because it is, unless you have a very consistent and thorough approach to do it. Because although what I showed you before makes it really clear that this is the role of the terminology and this is the role of the information model, there are more nuances to that, unfortunately, because the terminology has areas that overlap with what the information model also, and the information model overlaps in some way with the terminology. So the terminology, if we look at it isolated, is very good at representing the instances. This is a disease, this is a procedure, and these are the types of concepts with some constraints. I showed you the laterality example, that this type of body structure can have a left side and a right side, or a fracture can have these types of morphologies, and so forth. Information model is good at saying, well, representing the date of this procedure, the time, the people involved, the places. It's very good at doing that. And the relationship between record entities, for example, that the procedure, there was a performer of that procedure and a patient can have one diagnosis. So these relationships between these entries, an information model is super good at that as well. And then there's something they are both good at, representing situations, some contextual information, statuses of things, the absence or presence, uncertainty, family history, past history. So there is this yellow area where it becomes a bit tricky, and we get many questions in the implementation team about how to deal with that. So let me give you an example of this. So if you have a concept such as breast cancer, we looked at that before in the data analytics example. So imagine that you record the concept breast cancer in a user interface for family history. So the user interface you can imagine the heading saying, enter the family history disorders, and you would enter breast cancer there. You could also have a medical history. So for the patient that you are now visiting your department, you are recording the medical history of this patient, and the patient has breast cancer. You use the same concept in this user interface. You can also have a field, as we saw before, for the current diagnosis. Again, you enter breast cancer. So how should you interpret breast cancer will differ in each of these situations, because the context of where it was entered actually affects the meaning. So in one system, and this is another example. So that is one example where we apply breast cancer to different contexts, and in that way, breast cancer, the concept breast cancer gets an altered meaning. Here's another example where 3 hospitals have different ways of recording the same information. So in one system, we have a family history section, as we saw before, where we enter breast cancer. In another system, there's just a field maybe where we record family history of breast cancer. That is a concept in SNOMED, where the family history part of it, or the context, is embedded in the concept itself. And then we have a third system here where you state, well, this breast cancer, this problem is associated with the person in the family. So that's another way of entering the same information, family history of breast cancer. So you can see, if we want to do things consistently and we want to be able to interpret across various systems, these types of complexities and different ways of doing it can actually be a problem. Because imagine this, we are transferring this patient with a family history of breast cancer, and we're just sending the codes to the other organization. Because over here in the sending organization, we have, okay, the family history of breast cancer is relevant, so we need to send that information, so we forward the code. But if we just forward the code in isolation, the receiving system has no way of identifying that this was captured in a family history context. So this means that, so just by looking at this, the receiving receiver would interpret with right that the patient has a breast cancer when that's not the case. So how do we mitigate this? Well, you apply a model that can be understood by both the sender and the receiver. And that's why they need to go together. So in this case, this overall model will either have a place in the model that it would say, well, this is a family history, or it could be like in FHIR, there's a family history resource, and maybe that is the one that we forward. Do we have any questions to this?
There's no questions in the room.
All right, and no online. I'll just continue. So let us look at some of the principles for terminology binding. We've seen this before, how the various hierarchies in SNOMED actually fits different types of information in the electronic health record. So when you perform terminology binding, there are really overall two types of bindings. You can create a value set binding and you can create a meaning binding. A value set binding is when you have a data element in your information model. So you can imagine a model for holding the information about a fracture. And a fracture can have both a type and a location. And then the value set will say, well, the type, the values that we can enter into the type field should come from this fracture type value set. So the type of fracture can be displaced, undisplaced, open or closed. Maybe we have created this very simple value set. So this type of value set binding is again what you saw in the user interface demonstration. We have said that the value set for a certain field needs to come from this set of concepts. In that example in the UI, it was created by a query, and that query can then be expanded to an actual value set, as you have it here. The meaning binding is about what is this model about, or what is this data element about. So the meaning of the type field, that it can be displaced, undisplaced, open or closed, has to do with the associated morphology for the fracture, where the fracture, the meaning of the fracture model, is that this has to do with a fracture of bone. So when we bind to perform a meaning binding, it is to state what is the meaning of this field. Is it up? So that often represents a question. So instead of just saying enter type, the underlying meaning of type is what is the associated morphology of this fracture? But you would never see that question on the user interface, of course. Type would be enough for the clinician to understand it. And with a constrained set, it would also be easy not to select something that is not an associated morphology. A lot of animations here to show you that the type will will determine what you can select here for the type, and the actual question, what is the type, will have this type of meaning. I've already shown you this before, this is where we actually already started talking about value set binding in the earlier one, where we said what are the high level rules for value set bindings. And it really depends on what is it that I'm entering in this field, or what is it that I want this data element to represent. That should determine what types of codes from SNOMED that you can enter. I'll just continue here. The most simple term of a form for terminology binding are simple bindings, where you simply link a data element in your information model to a subset of SNOMED CT. And so you really need to be good at creating subsets. And Alejandro will be here after lunch telling you about SNOMED CT subsets and some principles. I will just give some high level that a subset is essentially a group of things that is smaller than the overall set of things that it belongs to. And SNOMED CT concepts can be like enumerated list. So you can create it, just handcraft your subset, and you can create it by a query. For example, as we've also seen in the data analytics example, all surgical procedures, all disorders with a morphology of inflammation. That's examples of rules. So there are different ways that you can create these subsets, but you can use subsets as a value set. And a value set is a subset of codes that you associate to a data element in your information model. So is a subset and a value set the same? No, but a subset can be used as a value set. A subset is a very general set theory term. So a subset just means in the context of SNOMED what it does in mathematics in general. But a value set is bound to an information model, so a context of use. So here you have an example where we have a medication order model. The medication may have a name, a dose, a route, frequency, a duration, and the route value set for the route can be represented by this subset here. And when you create the queries that can be your value set, you can use the expression constraint language. For example, you may have a data element where you want to say, well, this data element or the value set can be all the descendants of excision of appendix structure. And then your server can identify those codes if it supports the ECL language. And then you can also say not only descendants of appendix, but you can do something like, okay, I want to get that this field should be all types of nursing activities. So you have created a subset and you may have released that as a reference set in SNOMED. So a reference set is a data representation, or it's a format that we use to represent references of SNOMED CT components. And we may have in our edition a nursing activities reference set, and we can even use the expression constraint language to say, well, we want to bind this field to all the members of the nursing activity reference sets. The overall and best practice recommendations for terminology binding are these three you see here. You need, before you start to develop subsets and start to define your bindings, you need to know what are the data elements that you are including in your model. Then you also need to understand content requirements. Is there any logic or dependencies between the data elements in your model, and how can you use that, and how should this logic affect the bindings that you do? And then a very important one is, of course, that you make sure that the value set reflects the intended meaning and match the content requirements you have. Related to this principle of knowing what data elements are included, well, you can see that it does matter if you have a model to capture information about a fracture. So you may have two different models for representing information about a fracture. This is a more detailed model, and this is a very simple model. In this model, we can both enter, we have a field for representing the type of fracture, the body side for the fracture, and the laterality. Over here in information model B, we just have one field to say, this is the fracture. So this really helps you to understand what are the types of content that we need. Over here, we need some to bind the types to a certain value set. We need to bind the body side to a value set and the laterality. And over here, we need to find a good value set representing the fractures we want to record. So over here in model B, you could say we could have a fracture subset that we use as the value set, including fracture of humerus, closed fracture of hip, open fracture of bone. And these have very different, the binding could have been like all the descendants of fractures of bone. So that would include those that have some specific body side and have some specific morphologies represented. Whereas over here, if we have a type and we just said, give us anything that is a type of bone fracture, well, then we would also get fracture of humerus, closed fracture, as we had been before, that we could enter that here. But you can see that would actually overlap a bit with the body side field, because if then you entered fracture of humerus in the type field, and you then selected bone structure of femur, then you would end with a type of fracture of humerus in the femur, and that would be nonsense. That would be very low quality data, right? Because it would be so inaccurate and ambiguous. So if you are allowing anything in the type field to be a descendant of fracture of bone, you need to either populate the body side, because if you look up the concept fracture of humerus, it will see that it has a finding site of the humerus structure. So that can be pre-populated, just as you saw with the laterality before. So you need to make sure that it could also be that if you designed your subset so that you exclude anything with the body side, so that you force the user to be specific about the body side separately. So the first thing I described would be less work for the person typing, and the second one here would be require a bit more effort for documenting. So this is an example where the value set have been defined so that we exclude anything with a body side. And this one down here, we then have a body side value set where you say what is the actual body side or location of your fracture. Over here, we could then have fracture of femur, fracture of humerus, and you could still share that with the receiver. The second principle that you need to ensure that the subset reflects the intended clinical data. That relates to that you know where in SNOMED CT you find the concepts that are available. So if you want to create a subset of procedures, make sure you don't use concepts from other hierarchy. So if you want to include a concept such as blood pressure in your value set, you shouldn't use the blood pressure observation, because that's actually that you are right now observing the patient's blood pressure. The blood pressure taking is the procedure of taking the blood pressure, so that would be good. And normal blood pressure is the result of performing the blood pressure measurement. So if you have a value set of procedures, make sure that you only use procedures. You've seen the list of the many hierarchies in SNOMED. We have 19 hierarchies, and some of them are actually not intended to use for direct clinical care. The SNOMED model component is metadata technical, and you can learn all about it if you want. We have courses and documentation, and we have some other hierarchies here that are not for direct clinical data entry, so you can exclude them in your terminology binding as you start. Then we have the green ones over here, clinical findings. They are good to include for your problem list, the diagnoses, results, and so forth. Past medical history. Procedures are also useful for a variety. of things, situations, observable entities, and so forth. So this slide is really a guiding principle. So this you should exclude, this you can use for these things, and these are just some examples. And then we have the yellow ones here in the middle. For example, how is it you use a body structure? We also have a hierarchy for qualifier values. How do you use those, and substances, organisms? In order to use then these hierarchies and the concepts from these hierarchies in your implementation, you need to be very aware of how they are used in the information model. Yeah, there are also 2 stars here with the clinical finding and procedures, and that is because they could also be yellow, the clinical findings and procedures, because as I showed you with the breast cancer one in the beginning, if you used breast cancer in the context of a past history and so forth, you really need the context around it to understand it. Let me show you an example here where we have a user interface for a dermatology clinic. And here we have a diagnosis of elbow. So in that context, you use a body structure, and you can see, well, this concept is completely out of relevance to the diagnosis field, just if you use it in isolation. The diagnosis could also be mild, so you can use a qualifier in that hierarchy. You can find the things such as mild, severe, moderate, but that you have a mild diagnosis is not very helpful, right? Because what is the diagnosis? But you can see that if you had a diagnosis and you use the dry skin from the clinical findings hierarchy and the body side, and you then, instead of just typing elbow, you said it was the skin structure of elbow and it was the severity mild, you would certainly use the concepts that we saw over here, elbow, mild, in a context where you can actually understand why you are entering it. You are entering the body side and the severity for a diagnosis. So the elbow and the mild relate to dry skin. So here you are using these other hierarchies, but you're not using them alone. You're using them to qualify the diagnoses. We have a concept model. This is an overwhelming slide. I don't expect you at all to be able to read it. But this is just to talk to one of the features of SNOMED, is that every time we model a concept, we have a range of attributes. You have already seen some. You have seen finding side. You have seen the morphology, associated morphology one. We have a range of different attributes that we use to define concepts. And some of these attributes are used for clinical findings. Others are used for body structures and so forth. So when you have a concept, there are a range of relationships or things that you may you may want to use in your information model. So if you have a clinical finding and you want to say the body structure, then you can see, well, the finding site is in the this is the range for the finding site, the body structure attribute. So I know where those concepts should come from. If I want to say that clinical finding is have a causative agent, do we have that? Yeah. For example, if it's an allergy, you can see, well, the values for causative agent could be a substance. So here, these types of these rules here that are related to all of our attributes can actually help to guide you where to find concepts that you need for a particular data element in your information model. Yeah, so before, where we saw the dermatology one, where we had a finding side and a severity, you can see the values for the severity field should come from the severity subhierarchy in the qualifier value hierarchy, and the finding side attribute values should come from the anatomical or acquired body structure. Here you can see some of if you go into this qualifier value hierarchy, the severities, things like fatal, life-threatening, mild, moderate, so forth. And the anatomical or acquired body structures. And if it's a dermatology clinic, you may want to say not all the anatomical or acquired body structure, but you may want to say, well, all the skin and or subcutaneous tissue body structures. So only allowing those that are some skin structure. So these rules that I just showed you here is part of what we have in SNOMED called the concept model. The rules for how we can apply these attributes to specific concepts to represent their meaning. And we have an editorial guide where all of these rules are documented. And aside from a guide with which also elaborates more on some editorial principles, we also have a machine readable concept model where we use the ECL to say, well, the domain for this relationship type, so the source of the relationship should be this hierarchy, come from this hierarchy, and the values should be from this hierarchy. So we call this the machine readable concept model, and it allows computers to really utilize SNOMED CT to say, well, you can apply a body site to this concept, yes or no, and what hierarchy should it come from, and what are the values. So the machine readable concept model is really good for validation and also support in the creation. Yeah.
I just wanted to give you a 20-minute warning.
Thank you.
You may want to skip the MRCM browser demonstration and go to the examples.
I'm doing that.
Great.
I didn't intend to go into the MRCM, but this is a browser, just as the SNOMED browser. We have a browser where you can actually go in and see, okay, if I have a clinical finding, these are the attributes and these are the ranges. And if you want to look at it, the link is there available on the slides. Yeah, so when you have the domain, a clinical finding, like we had here, the diagnosis field, and the attributes will then, I think that comes here, the attribute, the body site and the severity, we have attributes for them. It relates to the FHIR or the information model that you are applying. So the clinical finding would be represented in the codable concept or the code for the condition. And the severity also has a field on its own in the condition resource. And the severity would be represented here, and the range for severity is as I showed you before. So that also fits well into the condition resource, and the finding site is the body site for the condition. But the point here is that the actual condition, the code for the condition, is the one that we get for the diagnosis, but then the site and the severity is also used to represent the condition. So all these values are used within a single model, being in this case the condition resource. So this is also where to show you that you never just send the diagnosis or the body site alone, you send it in the context. Because if you then collate them all and say, well, the code was this, the severity was that, and the body site, you get the receiver a full picture of what is the condition and the additional information, giving them a lot better opportunity to derive what was actually stated. And the same goes if the information model that you're talking about is for data storage. You can also consider this as like a data model in a data storage model. How do you store your information? And in a similar way, you need to consider, do we want a field in our data store for the severity separately, or do we just want a single code for that for the whole diagnosis? So you also need to consider that when you design your data storage models. You have seen the UI, so I'm not going to show you that. I'm going directly into these scenarios here. Let's see how far we go. Let's start with the allergy example. So when you have want to enable in your system the recording of allergies, that you have an allergy to shellfish or cats or flowers or pollen I don't know, some medications. You can see here, if I'm recording shellfish, that I'm allergic to shellfish, there's a range of things that you can consider. I want to use shellfish, the organism. I want to use shellfish-free diet. So this is similar to the malignant melanoma I showed you before. But there's a range of things where you can say, well, this could be used to record that this patient has an allergy to shellfish. So first you need to decide on how is it you're recording this information. And in this situation here, we have decided that we want to record not the allergic condition, but we want to record the cause of the allergy. So we may have a form, so a context where this is the context of allergy, and this just documents whether I'm allergic to shellfish or cat or plants or dust. So here, shellfish, the substance. So it's not allergy to shellfish that we would select, even though he has the condition of being allergic to shellfish. We here document the cause of this allergy because we have the context explicitly stated that this is an allergy and this is the causative agent. In another situation, you may have decided to record the actual allergic conditions. So when you type shellfish, you actually mean I'm allergic to shellfish. So in that case, it would be absolutely okay to use the allergy to shellfish. So you need to agree upon what is the approach that you're using. If you look at the allergy to shellfish concept in SNOMED, you can see that this concept has defined as a type of allergy to seafood. It has a realization of allergic process, and it has a causative agent of shellfish, the substance. So in the first example, we use the substance. In the second one, we use the allergy to shellfish concept. So you can see here that there are actually two approaches, high level, that you can take to record an allergic condition. Do you record the condition itself, or do you record the causative agent of your condition? And we actually have a clinical reference group at SNOMED International. So that's a group of experts, and they have been discussing best practice approaches to record allergies. And we have an implementation guide for that. And the thing is that they have identified that these two approaches, you can't argue which one is better than the other, but they have emphasized that these two approaches exist, but also that they can function very well together. I'll just show you here. We have a guide, an allergy guide, where you may have a problem list in your record where you say, well, this patient has some problems. So maybe there's hypertension. So I'll add this. Nothing is added to the patient's a list of substances that it's allergic to because the problem that we have recorded is a hypertensive disorder. Let us now say pollen allergy. Allergy to pollen. I'll record that in our problem list as well. And now we can highlight that, okay, that's an allergy intolerance condition. And the substances that this patient is allergic to is pollen. So the problem is allergy to pollen, but the substance that the patient is allergic to is pollen. Let us look at if we had a dedicated user interface to record allergy information. It may be a bit detailed one here. We can say, well, in this case, and this is the FIRE resource, there's an allergy intolerance resource in FIRE. And right now I'm using the propensity, I'm not using the propensity-based model. I will just right now use the, I'll here just say shellfish, for example, and then I get the disorder. So here we are recording the disorder and the substance or product is derived. And down here in the allergy intolerance, so that already states that what we are documenting here has to do with an allergy. But the coding that we are using here is because we are not using the propensity-based model, we derive that the shellfish so the substance. So you can see that the code for the allergy and the substance is the same, because in this case we have decided that we want to just record the causative agents. If we had decided that we're using a propensity-based model, you can see, well, in this allergy intolerance resource, the coding is the actual condition where the substance is shellfish. So that's two different approaches, and you can see how it looks. And actually, if you're regardless of which one you use, you know that it is an allergy, and you know what the causative agent is. And when you know what the causative agent is and that it's an allergy, you can derive allergy to shellfish, even though it's not may not be present in the actual resource. So take a look at this. It's available on SNOMED. See here, snomed.org/allergy demo. That will take you to this demo. Just take one more example, Kai, if that's fine.
Yeah, great. I just wanted to mention, obviously, Anna's shown a lot of examples where SNOMED can help with improving the quality of data that's captured, ensuring that the data is from the right hierarchy, so it has the right meaning, but also other fields in the data input, like user interface, can be constrained to ensure that there's good consistency between the data and, the different fields all relate to each other well. It makes it difficult to capture nonsense. So to enable this sort of functionality, a lot of calls need to be made to a terminology server, and often the SNOMED query language is used to support these constraints. So if you're thinking of designing anything like this, please involve us. You can reach out to us on implementation@snomed.org. We can help to design these sorts of things. And the demos are a great way as well. A lot of the demos will show the ECL statements that are being used to constrain these interfaces. That's great. Thanks, Hannah.
Thank you, Kai. That's great. Yeah, I can just second everything you said there. Okay, so this example is about the recording of malignant melanoma. We have already looked at this in another context, but just explore these, because last time I just talked about what would be good to record in a current diagnosis of malignant melanoma, but how is it that you can actually apply some of the other types of malignant melanomas? So you can imagine a histopathology report from a lab system, a patient summary, a diagnosis, and a current encounter, where you have both a diagnosis and a body site. So in the test results of a histopathology report, you may want to record the morphologic abnormality, but it's actually in the patient record that you would use the diagnosis, and it's in the current encounter where you would document the overall malignant melanoma.
Anna, I've got a question.
Yeah.
Can you go back to the previous slide?
Yeah.
What is what's a morphologic abnormality?
A morphologic abnormality is at the cellular level. So what is the actual morphology, or in this case, what is the abnormal morphology of a condition? So all conditions have a certain morphology. A morphology can be a fracture. So it's not the disorder of a fracture, it's the fact that the bone has fractured. And a malignant melanoma is not the disorder of a melanoma. It's at a cellular level that your cells have a abnormal structure. Yeah. So I don't know if that explains it.
Yeah. So it's
maybe
like
you can explain it differently.
So it's like describing the change to the body structure, rather than that a patient has had this change. They're slightly different, aren't they?
Yeah.
Yeah, that's fine. Thank you.
Well, I want to show you a terminology binding demonstrator so that you can actually go and try this on your own. So if we want to make an observation of or the question that we are asking here is, what is the condition? So the condition of this patient, so we'll give it a text, and I'll just say that it's, I can restrict here to what is it I'm observing. So I can say something about malignant. I'll see if I have something. Malignant, so I can observe the risk. I can histologic type of malignant neoplasm. Okay, so that would say, so if my question, so then it wouldn't be the consistent, so to see type of malignant neoplasm. So this is just an example. So if we have here a question set, what is the type of malignant neoplasm? And the observation that we are saying, so the meaning of our binding is that we are documenting the histologic type of our malignant neoplasm. I could say an autocomplete, and then I can construct an ECL to say, well, in this case, I want all the descendants of, and I also want it itself, malignant melanoma. And in this case, because it's a type, so we know that it's not the disorder itself, it's the type of malignant neoplasm. I could type it here. And I can add this binding. So now we have a field which has a binding. So the question is histologic type of malignant neoplasm. And here we have malignant neoplasm. So if we go back to the slides here, looking at these, we could say something with nodular. We could choose that. Now we get nodular melanoma as my result. And this has been bound to all the different types of morphologic abnormalities. Let us try to create another line. So we can say malignant melanoma could be the question. And then the question could be some malignant melanoma. But here we don't have like an observation. Maybe we could just say, well, this is, will open for all clinical findings that we could have. So we know that this is a type of clinical findings, but we want to we want to constrain it, be able to search for the specific type. Again, I'll just say autocomplete and say malignant melanoma. I'll use the same for binding of the questions and the answer here. Need to use the builder.
Yeah.
And in this case, I don't want to search for only the I want to say these are the actual disorders that I can search for. So these, I'll add this. So now we have one where we record the actual type, but down here we are recording the malignant melanoma. So now we can say, this, I want to record a malignant melanoma of my chin. And then you can say, well, okay, I get the malignant melanoma of skin of chin. Because here we have constrained to all the descendants of malignant melanoma. And when you go into the browser, you can see that there are very many different body sites and different types of malignant melanomas that you can choose. So if I wanted to search for something in a malignant melanoma on the nose, you can also do that very easily. You can see I don't get many options. If you were a clinician using this, you don't even have to, it's just, I want something on the ear. And then you would probably get something. Very few options, easy to find it. You know that everything here represents a malignant melanoma of ear because the binding has been done properly. If you were in a histopathology report, you would do something like that up here. That's a few examples, and these demonstration tools that I've shown you, many of them are really available so that you can go in. We have a portal called implementation.snomed.org. You can go in on the showcase, you can click demonstrators, and here you can see the one I've shown you today is the UI demonstrator, the allergy documentation demonstrator, and the one I just showed you now is the terminology binding demonstrator. Yeah, so I think we'll leave it at that. I'll just see what the last example that you'll see in the slides that my Ellen Elizabeth will make available to you has to do with a procedure and the context. Is it a planned procedure? Is it a requested? Has the procedure been done? So that types of contextual information. So you can read through this example, and the last slides will talk about interoperability. And I hope that they are somewhat detailed enough so that you can understand what we are trying to illustrate with them when you go through the slides. So I'll stop here and leave you to any questions.
Yeah, I was wondering if how to manage conflicts between different models, for example, in FHIR and SNOMED with cardinalities, because we were shown only example with ungrouped attributes within FHIR, but in SNOMED, the model, we could code we could model concepts with grouped attributes. So how to manage that if there are conflicts between the models?
Yeah, so for example, you could have a procedure that's got many body sites. That's not easy.
That's a good, no, that
it's a really good question. So
oh, yeah.
I suppose, the FHIR model in general will let you put multiple body sites, but maybe you've got an implementation guide, for your organization or nationally that says you can't. So maybe then you'd have to split it into two procedures, one on each site. There's something the terminology server can help you with using ECL queries. I guess you'd have to look up the equivalent procedure for that or single body structure. But yeah, it's not easy. It's a good question.
We have what is a good example of a concept with multiple procedures. It is, what is it we have? One exploration and, okay, I'll see if I can find it. Just trying to share again.
Another way to approach this is to construct a value set, to constrain what can be entered. And maybe you force the clinicians to not use procedures that have two body sites. The other thing is sometimes procedures have like an indirect site and a direct site, and that's where they've got like a point of access and then the point of the body structure that's actually been operated on. So in that case, maybe you just take the one that's been operated on, the direct site.
Here's an example. Yeah. Okay. Yeah, I understand your question now. Initially not, but this one is good. Like, right, this one is a nipple exploration with excision of some duct, and here you can see the procedure site. So this both is a direct procedure site of this duct structure. I don't know what this is. If there are clinicians out there on the call, you will probably know this. I know what nipple structure is, but here in this case, either you would have two, as Kai is saying, this one could be extracted into one procedure, and this is another procedure. The problem is then that you lack the fact that it was one procedure where both things were done. And I think that is the issue that you are articulating. So yeah, maybe, yeah.
Anna, in this example, can you switch to the inferred view, please? Okay. the reason I asked is because sometimes if something's got multiple sites, if they are subtypes of each other, then the inferred view, which you should always use the inferred view, it may collapse them into a single item. Of course, a duct isn't a subtype of the nipple, but it's just good to look at the inferred view.
Yeah. Yeah, I think that is a very good example, and definitely it's an example where you need, as an implementer, to make decisions about how you do this. If this is a case where you have very many occurrences where multiple is included, then you need a very strict way of handling it. But otherwise, as Kai was saying, maybe there is a comment. I'm thinking right now. So you would of course record this one in the code, but what would you then capture in the body side? You could also find if there is a common denominator. I'm thinking about if there is a common denominator of these that could maybe be added in the body side field. You'll still have the access to the actual body sides from this concept, but in order to not leave the body side field empty in the information model, you may want to see if there is and you can do that automatically.
Record body structure, couldn't you? The common ancestor.
Yeah.
The breast structure.
The common is very high level because it's a breast structure, because lactiferous duct structure are inside the breast and the nipple on the outside. So.
Outside, yeah. So you can, but that would be, that's what I mean. So you would have at least the body side field would then, if you do that, regardless of that it is high level, it's lower level, it's more granular than, say, it's a body structure. So it will have some value if you want to say, well, give me any procedures that have been done on the breast structure. You would still be able to do that just looking at the breast or the body side element. And if you want to know exactly what are the body structures that were, you would need to go to the code field, so the actual condition code, and derive the actual body structures. Yeah.
Okay, thank you.
But it's a good example, and it is it's definitely something that we'll have to go back to for considering. We haven't had this question before.
So to wrap up, you can see that SNOMED allows you to record the same information in many different ways, and you really need to think carefully about what your information is going to look like. There's different concerns, of course, interoperability and how the record will be transformed to FHIR, which that question was about. Also, what's the best user experience for clinicians? How's the data going to support the reporting you need to do? How's the data going to support clinical decision support? And maybe also research and analytics as well. So there's a lot of different concerns that you need to consider. I suppose FHIR is a good one because there's already some constraints there. That's a good thing to start with, but it shouldn't always drive the decision of your information model design.